Hi friends, in this video we see electric circuit analysis based questions asked in various TRB and TNEB exam. The first question is in Y2 delta transformation of resistance, one arm of, it is not aim, it is arm of delta has what you call dash value of resistance. So we know it is Y2 delta transformation. Y2 delta transformation, the resistance, equivalent resistance is given by, we know the delta value is given by what you call sum of, right, or sum of product of individual resistance pair divided by opposite resistance, divided by, it is called R opposite. Okay, so sum of product of individual resistance pair. So here RA, RB, RC they have given. So it is RA, RB plus RB, RC plus RC, RA. So opposite pair means denominator we should have only one resistor. What is that? Opposite maybe RC. So RC is there. So this is wrong. These two are wrong because in denominator we have only one opposite resistance. So this is wrong, this is wrong. Fine. So either A or B must be right. So opposite resistance, both the things are talking about RC. So it is RC. Right. So if we simplify RA, RB by RC plus RB plus RA. So the equivalent resistance value is RA plus RB plus RA RB divided by RC. So it is given in the option A. So option A is the right answer. Okay, right. Second question, the minimum number of resistors required to form a series parallel circuit. See, if you want to form series circuit, we need minimum 2 resistors, right? Okay, I can say this is V. This is resistance in series R1, R2. If I want to form parallel V, this is also a parallel connection. So it is R1, R2. This is series. This is parallel. But what they ask is series parallel combo. Series parallel combo means, let us assume it will be like this. So by using 2 resistor, I can generate either series circuit or parallel circuit. But they ask what is the thing, series and parallel. So I should have both series and parallel. Let us assume it is R1, R2. Now we know these two are parallel with series. So series and parallel means minimum I need 3 resistors. So option D is the right answer. Next, 2 coils are connected in series, have an equivalent inductance of 0.4 Henry when connected aiding and equivalent inductance of 0.2 Henry when connected in opposing. Find mutual inductance value. So we know the equivalent inductance in aiding is given by L equivalent is L1 plus L2 plus 2M, which is given by 0.4. Similarly, L equivalent for opposing, that is given by L1 plus L2 minus 2M is equal to 0.2. What they ask is, here L1, L2 are self-inductance. M is mutual inductance. What they ask is mutual inductance, so I subtract. So 4M is equal to 0.2. This indicates M is equal to 0.05 Henry. Whether we have 0.05, no. So I think 0.15 will be the right answer, right? So that is the point. Okay. Right. Next, for the given circuit, find the current at the resonance condition. It is series RLC. For series RLC, I resonant is given by V by R only, right? So because Normally what is I? I is equal to V by Z, where Z is given by root of R squared plus XL minus XC whole square. But at resonant, XL is equal to XC, it will be cancelled. V by R square, that is V by R. Okay, so V is 24 volt they have given, R is 0.2 ohm. So I is equal to 24 divided by 0.2, that is equal to 120 ampere. So the answer is option A, 120 ampere. Next question, choose the answer related to mutual, correct, incorrect, that is very important. Wrong answer. Mutual inductance is measured in Henry, that is right answer. Right, M21 is equal to M12, that is also right answer. The current in coil generates magnetic flux in the same coil and a nearby coil, inducing a coil. This is also right answer. Mutual inductance may appear either as positive or negative. No, it is always positive. So this is a wrong answer. That's what they ask. Okay. Next one, the total impedance of the circuit shown in figure. So it is RL circuit, right? So what is R? Z total impedance is given by, for RL circuit, R plus JXL, right? So here R is 10 plus 30, 40 ohm plus J, XL is 2 pi FL. Here we have two resistance, so 2 pi FL1 plus 2 pi FL2, right? So I can write 40 plus J 2 pi, F is 100, that's F100 is they have given, L1 plus L2 70, 20 plus 50. So 2 pi FL, I take it common, so 20 plus 50 Henry, millihenry into 10 power minus 3. If you simplify, what you get is 40 plus J, 43.98 ohm. So the answer is option A, right? Okay. And the next question is, choose the wrong statement in the nodal analysis. In the nodal analysis, the choice of reference node does not. Choice of reference node affect the operation of the circuit. Yes, true. Right? Here they ask wrong statement. Very important. So this is right statement. Choice of reference node charge the voltage across any element. That is also right one. It will alter the potential difference between any pair of nodes. Yes, of course. What is the only thing? It will not. It will affect the voltages of various nodes. Yes, that is correct. But they are telling the choice of reference node affect the voltages. Right? They are telling it is not. So it is the right answer. For this question, it is a, they ask wrong statement. The choice of reference node affect the voltages of various nodes. That is true, but they are telling it is not. So it is a correct wrong answer. Okay. So option A is the right answer. And the next question is, when two-port networks are connected in parallel, it is convenient to use. See, we always know that whenever we are having a parallel circuit, it is good to use admittance, right? So when two-port networks are connected in parallel, go for admittance parameter, which is nothing but Y parameter. So option D is the right answer. Okay, fine. Next one. So next, in RLC series circuit, the impedance at resonance. So in RLC series RLC, impedance Z is given by V by root of R square plus XL minus XC whole square. At resonance, we know at resonance XL is equal to XC. This implies at resonance Z is equal to V by root R square, that is equal to V by R. And we have only impedance, sorry, it is I, not Z, please forgive me. This is I, so this is Z, right? So at resonance, so what is my Z? Z is equal to R. So at resonance, Z is equal to R. So option B is the right answer. This is current resonance. At resonance, impedance is equal to resistance. Okay, the next question is in the figure 1, RA, RB and RC are 20, 10 and 10 ohm respectively. The resistance R1, R2, R3 are, right? So what is R3? R3 is this one they are giving. So whenever I want to find this resistance, it is equivalent star. So what should be the equivalent resistance? You see the product of the resistance connected with this arm. So it is 10 and 20. So 10 into 20 divided by total resistance. What is the total resistance? 10 plus 10 plus 20. So it is 5 ohm. So R3 we got 5 ohm. Next, let us go to this arm. This arm is given by R1. R1. So again follow the same rule. This is 10, this is 10. Find the product of the resistance connected with the arm divided by total resistance. 40. 2.5 ohm. Next, R3. Sorry, R2. R3 we found. So R2 we will find. What is R2? This one is R2. So what are the product of resistance connected with this arm? 10 and 20. So 10 and 20 divided by total resistance 45 ohm. So R1 2.5, R2 5, R3 5. What is the option? 2.555. Option A is the right answer. Next. Sorry. To the equivalent inductance of coils, two coils A and B connected as shown in the figure. Here you see here current enters at this point and leaves at another point. So another node. So total inductance is given by this inductance L1, this inductance L2 minus 2 mutual inductance. Right. So option instead of L they have put XL1. Okay. Suppose if current goes like this, if the dots are placed at this location, then L is equal to L1 plus enter at both inductor at the same point. So it is L1 plus L2 plus 2M. Right. So it is series 8. I call this as series aiding. This is series opposing. Instead of L, they have written XL1, XL2. So it is XL1 plus XL2. Mutual inductance is 2 minus 2M. So here minus 2XL. So option A is the right answer. Next one, what shall be the value of R if it has to absorb maximum power? So R is a load resistance ratio for maximum power transfer. RL must be equal to R Thevenin. So I want to find R Thevenin. If I want to find R Thevenin, what I need to do? I short the voltage and open the current source. Here we have voltage source, short it. Remaining resistance is 8 ohm. Here 4 ohm. Leave the load. So load I leave as it is. From here I have to see R Thevenin. So R Thevenin is a equivalent resistance. R Thevenin is equal to 8 into 4 divided by 8 plus 4. 32 by 12. So 8 by 3 ohm. So option B is the right answer. Right? Okay. Next one, which one of the following theorems is a manifestation of the law of conservation of energy? Law of conservation of energy is the manifestation of diligence theorem. Okay. The Norton's equivalent circuit of the figure shown in the figure 2 is drawn 1. What is the value of ISC and R equivalent? Right? So first I find I short circuit. I short circuit I have to find take the voltage source as it is, resistance 2 volt, 3 ohm. This is 4 by 5 ohm. Short. So short the load terminal. So I have to find what is the current flowing through this current I have to find. I apply node analysis V at this node V. So apply KCL at node V. So V minus 2 by 3 for this branch. Then for this branch it is V by 2. For this branch it is V by 4 by 5 equal to 0. Right? Okay, if I take V outside, V into 1 by 3 plus 1 by 2 plus 5 by 4. This 2 by 3 goes that side, 2 by 3. If I simplify this, what I get is V is equal to 2 by 8 by 15, 8 by 25. So V I got, okay, V is 8 by 25 volt. I got it. Now I got V. So what is the current flowing through this short circuit terminal? I is equal to V by R, 8 by 25 divided by R. This is R, right? I, this current. R is 4 by 5. So 4 by 5. So I is equal to 2 by 5 ampere. This is what I short circuit. So I short circuit is 2 by 5 ampere. Next, R Norton. R Norton I have to find. R Norton is nothing but R Thevenin. That we know how to find. Short the voltage source, discard the load. So I short this voltage source. Here 3 ohm, here 2 ohm, right? Here 4 by 5 ohm, discard load. So here I have to find R Thevenin. So simplify this, R Thevenin is 3 into 2 by 5 plus 4 by 5. 6 plus 4, 10 by 5, that is equal to 2 ohm, right? So ISC is 2 by 5 ampere, R Norton is 2 ohm. So 2 by 5, 2. So they ask R equivalent, it is ohm. 2.5, 2 by 5 ampere into 2 ohm. So option D is the right answer. Next one, match the list. So here they have given RLC relation and what you call as a response of the system, right? So this is very important question. Okay, so from this what we are understanding, here we know when R is equal to 0, it is undamped system, right? When R is, okay, when R is greater than 2 root of L by C, it is damped oscillation, right? When R is equal to 2 root of L by C, critical damping. When R is less than 2 root of L by C, it won't oscillate, non-oscillatory. So I think option A matches with this exactly. So 0 undamped, greater than damped, equal to critical. It may be we can call underdamped or non-oscillatory, right? Okay. Next one. If R in RLC circuit, R is equal to 8 ohm, L is equal to 4 Henry, C is equal to 1 by 4F. What is the natural response? Now only we saw. I have to find R root LC. R is 8 ohm. 2 root LC I have to find, then compare. So 2 into, this is L is 4, C is 1 by 4. 2 into root 6, it is 8. So R is equal to 2 root of L by C. So it is critical. 2 root of L by C is 8. R is equal to 8. So it is critically damped system. Next, find the voltage across AB in the circuit shown in figure. So I have to find it is A, it is B. I have to find it. So if I find this way, it is very impossible. So I redraw the circuit. Change like this. I redraw. Fine. So A comes here. Is it okay? So next it is what do you call 7 volt. This is 4 ohm, 3 ohm. Next A to B, it will go like this. Here I didn't touch anything. 8 ohm, 10 volt, 2 ohm. This is A, this is B. So I find the voltage between A and B here, right? This is VAB. So I need current flowing through this, current flowing through this, then add. Okay, so I apply KVL here. So what happens? So it is current flowing through this. It is 4 ohm plus 3 ohm, 7I plus 7 volt equal to 0. This implies I is equal to minus 1 ampere. Fine. Okay, I is equal to minus 1 ampere. I is equal to minus 1 ampere means what is the voltage drop at this terminal? 4 into minus 1 minus 4, right? So minus 4 volt here. Voltage across this 4 ohm is minus 4. Minus 4 means it should be minus. This should be plus 4 volt. I can express like this. Okay, this one 4 volt we got. Here 5 volt. Next I have to find the current through this. So here what I do, I take this direction. So it is 10. First it is meeting 10 volt. I apply KVL here. 10 plus 10I, right? 10 plus 10I means 0. This implies I is equal to minus 1. So I across 8 ohm is minus 8 volt. So minus 8 volt means here it is, this is the current, so it is minus 8 volt. So 8 volt. Okay, now I want to find A to B. So from here I have to start. Here what is the drop? 4 volt. So VAB. VAB. So here it is 4 volt plus 5. V. Here it is meeting plus first. Here it is meeting plus first. Here it is meeting plus first. It is the way I am going. So 4 plus 5 plus 8. 17 volt. Right? So the option is option B. Right? Current voltage between A and B is 17 volt. Next. Current through the voltage source in the following circuit. So what is the current through this circuit? They are asking. This is very simple. What is the thing? Here we have 20 volt, right? So I apply as usual KVL. Here V is 20, R is 10. So I is equal to V by R. So 20 divided by 10, 2 ampere. So here 2 ampere comes. Here 0.5 ampere comes. So what should be the voltage current here? 2 plus 0.5 as per the KCL at this node. Total current is 2 plus 0.5, 2.5 ampere. That current flows through this 20 volt. So the answer is 2.5 volt. Next one, a DC voltage is applied at a time t0 to a series RC circuit. What is the steady state current? So let us assume this is RC. He applied DC. This is R, this is C. See, for DC, capacitor is open. C is open circuit for DC. So what should be the current? I0. So the answer is option C. Okay. Next one, 20. Okay. Yeah, bulb draws. Okay. Yeah, 100 watt electric bulb draws. What is the power? They have given 100 watts. 20 volt. V is equal to 20 volt. 50 hertz supply. So 200 volt. What should be the current? So first I need power in terms of current. I know pi V is equal to I square R. So I need R. From these two I can find, because P is equal to V squared by R. This implies P is equal to 100. 200 into 200 divided by R. So this implies R is equal to 400 ohm. R I got 400. So P is, I know, 100. I squared into R 400. This implies I squared is equal to root of 1 by 4. That is root of 0.25. This implies I is equal to 0.5 ampere. So I is equal to 0.5 amps. Okay. Next one, at resonance frequency, RLC series circuit draws maximum current due to, we know at resonance frequency RLC draws maximum current due to the difference between the capacitive and reactant and inductive reactance is 0. We know already, just now I told, at resonance XL is equal to XC. So what should be is impedance? Impedance is equal to root of R squared plus XL minus XC whole square. So this is 0. XL is equal to XC 0. So it is R. So I is equal to V by R. Minimum resistance. So maximum current. I R minimum maximum. So I max. So option A is the right answer. Next one, a series RL circuit is connected. A series connected load draws a current of I of t is this one, with the source current voltage is this one. What is apparent power and power factor? So I of t is 4 cos 100 pi t plus 10 ampere. V of t is 120 cos 100 pi t minus 20 volt. What is the thing they ask? Apparent power. Apparent power is equal to IRMS into VRMS. So this is I max, maximum value. This is V max. So IRMS equal to I max by root 2. VRMS is V max by root 2. I max is 4 by root 2. 120 by root 2. 480 by 2. It is 240. 240 volt ampere. So 240 is the answer. So 240 is the answer means this is wrong. This is wrong. Next we assume power factor. Power factor is 5 cos theta v minus theta I. Cos theta v voltage angle. This is theta v. This is theta I. Theta v minus 20, theta I 10. So minus 20 minus cos of minus 30, that is equal to cos 30 root 3 by 2. Root 3 is 1.732 divided by 2, 0.866. Okay. So 0.8 leading or lagging 240, 240. Leading or lagging, here you see voltage is I is 10 degree, V is minus 20 degree. Current leads voltage, so it is leading. So option I leads V. Option C is the right answer. Okay. Next one. Superposition theorem is applicable for, they ask not applicable. It is applicable for voltage calculation, it is applicable for passive element bilateral, but we cannot use superposition theorem for power calculation. We can even use for current calculation. Current we can find by using superposition theorem. Okay. Next one, time constant of the network shown in figure. We know it is RC. Right, for RC circuit, tau is equal to RC at steady state. Right, so what is the at steady state? It is connected. What is R and C? R is nothing but Thevenin's resistance. If you are having more than one resistance, R is equal to R Thevenin. So I can find R Thevenin as short the voltage source. This is R, this is 2R. So R into 2R divided by R plus 2R. So it is 2 by 3R. Sorry, 2 by 3 into R. Numerator R square, denominator R. So 2 by 3 into R. Tau is equal to R into C. R is nothing but 2 by 3 into R into C. So 2RC by 3. Option D is the right answer. Next one. When a DC voltage of 100 volt is applied to a circuit having R 10 ohm, L 10 ohm connected in series, the current after 0.1 second after switching on and time taken to reach half of its final value. So V they have given R 10 ohm, L 10 Henry. Current after 0.1 second. First we find RL circuit, I is equal to V by R e power minus 1 minus e power minus R by L into T, I of T. V is 100 by 10, 1 minus e power R by 10. They ask what is the current after 1 second, 0.1. So I of 0.1 into T is 0.1. If you simplify, what you get is 0.96 amps. So B is wrong, D is wrong. It is 0.95, it is 0.95, either A or D. So what is the time taken to reach 50% of the final value? So what is the final value? Final value I infinity is nothing but I is equal to V by R. So V is 10, R is, V is 100, R is, so it is 10 ampere. Half of the final value, 1 by 2 of I infinity, 5 amps. So time taken to reach 5 ampere. Again follow this equation. Now what should be the I of T? What is that? I of T 5, V by R 10. Time taken to reach R by L is 10 by 10. What is this time? So it is the initial value. If you want to reach not 0.5, it is 5. So this is initial current. This is the final value 5 ampere. So what should be the time taken to reach this 5 ampere? So if you simplify, what you get is T is equal to 0.693 second. So the answer is 0.9 okay into and 0.693 seconds. So option A is the right answer. Already we got 0.95, right? I of T, I of 0.1, it is 0.96. So time taken to reach half of the final value 5 amps. So it is 0.693 second. Okay. The next question is the charge when C is equal to 0.001 microfarad and V is equal to 1 kilowatt. So we know the relationship between charge and capacitance and voltage. Q is equal to C into V, right? So C they have given C is 0.001 micro, so it is 10 power minus 6. Voltage is 1 kilo, 1 into 10 power 3. So this indicates Q is equal to 1 micro coulomb. So option B is the right answer. Next, a 330 ohm resistor is in series with the parallel combination of 4 1 kilo ohm resistor. Undervolt source is connected to the circuit. Which resistor has the most current through it? So what is the thing? 100-volt source. 330 ohm is in series with 4 1K. 4 1K are in parallel. Okay. So what they are asking, which resistor out of this, which resistor, which configuration has the least resistance? Okay. First one 330 ohm. Second one is first one 330 ohm. Second one parallel combination of 3 1 kilo ohm. Parallel combination of 3 1 kilo ohm means R equivalent is 3 1 kilo ohm means R by 3. So 1 into 1000 by 3 is 333.33 ohm. This is the second combination. Parallel combination of 2 1K. So R equivalent is 2 1K means R by 2. So 500 ohm. Okay. Fourth one 1 kilo ohm, that is 1000 ohm. So out of this, which is having a least resistance value? Out of this one 330 is the least resistance. So it consumes, it allows more current. Right? We have 330 ohm, option A 330 ohm, option B 333, 500,000. Out of this has least resistance, so it will allow maximum current. So 330 ohm resistor allows maximum current. Okay. Next one, a network has what you call 10 nodes and 17 branches. The number of different node per voltage. So number of node per voltage is equal to n minus 1, where n is the number of nodes. So node per voltage is 10, node is 1, 10, 10 minus 1, 9. So option B is the right answer. Next one, cut set gives the relationship between, it is a direct question, it gives the relation between branch voltage and the tree branch voltage. So option B is the right answer. Okay. Next one, this is 29, I can see. Okay, so let us see, it is 29, others are changing. So here a network has 7 nodes. You see n is equal to 7 nodes, 5 branches, b is equal to 5, b is equal to 5 branches, right? The number of, sorry, by 5 loops. Okay, L is equal to 5. L is equal to 5. The number of branches, B, they are asking. So L is equal to B plus N minus 1. So this implies B is equal to, right? So B, they are asking, B is equal to, okay, L is, sorry, L is 5, right? So, okay, here it is. Sorry, here L is equal to B minus N plus 1. So this implies L is number of loops, so 5 independent loops. B is number of branches, that's what they are asking. B minus N number of nodes is 7 plus 1, so that is B minus 6. This implies B is equal to 5 plus 6, 11. So option C is the right answer, 29. next to 30, this must be 30, right? So what it is telling, three equal resistance of 5 ohm are connected in delta. What is the resistance of one of the arms of the star circuit? So whenever they are having equivalent resistance in delta, what is the equivalent star is Ry is equal to Rd by 3, right? So simply you put 5 by 3, it is 1.33. All the Y network has equivalent resistance of 1.33 ohm. So answer B is the right answer. 30, this is 31. Let us see. So here what they are asking, superposition theorem. This question they are asking regularly. Already we saw this answer. Superposition theorem cannot be used to calculate power. So answer option C is the right answer. It can be used to voltage response, current response, but cannot be used for power response. Next to 32. Maximum power is transferred to the load when load resistance equal to source resistance. Option A, direct question. Okay, next one. This is 33. What is the thing they are asking? What is the phase angle between the capacitor and the applied voltage in parallel RC circuit? It is 90-degree direct question, right? In parallel RC, the phase angle between current and applied voltage is 90-degree. Okay, 34. What they are asking, true power. True power is nothing but VI cos theta. So option A is the right answer. Next one, 35. For a two-port network, H parameters H11 and H12 are obtained. Right? So this is another question. Let us see this question. Okay. So here you see, we know H11 value can be written as H parameter can be written as V1 is equal to H11 I1 plus H12 V2 I1 I2 V1 I2. This is what H parameter equation. H21 I1 plus H22 V2. What they are asking is H11 and H12 value. H11 from this we can find H11 is equal to V1 by I1 provided if V2 0, this term will be 0. So V2 is equal to 0. V2 is output. So output voltage is equal to 0 means output is short circuit. Similarly, what they are asking, H12. H12 I can find from here. Okay. H12 from this H12, if this will be equal to 0, then it will be H12 is equal to V1 by V2 provided I1 0. I1 means input. So input current 0. Input current 0 means input must be open circuit. So output should be short circuit, input must be open circuit. That is the answer. Okay. So this question number 35. Output must be short, input must be open. Let us see. So output must be short, input must be open, opening input. So both the things are right. Then only we can find, right? So I think something wrong. So you can choose anything, right? If I want to find H11 input, what is the thing you see? If you want to find H11, I have to short the output. If I want to find H12, I have to open the input. Okay. Next. This is question number 36. Okay. What they are asking? For the network source voltage Vs I0 they are given. What is Vs? Right? So let me redraw this circuit. How I'm going to redraw, let us see. Right? So this 4 ohm will be as it is. Here this 6 ohm. Here 6 ohm. This is, let us make this reference. Here it is 7 ohm. Here it is 8 ohm. Vs 12 ohm. Right, and they are telling I0 is 7.5 milliampere. This is 7.5 milliampere. It is 6 ohm, 7.5 milliampere. These two are parallel, so it must also be 7.5 milliampere. Current divided equally. So if it is 7.5, it is 7.5, it must be 15 milliampere, right? So 15 milliampere we got. Next, what I have to do? I simplify this circuit. So it is 6, 6. You see, I find the equivalent circuit. This 12 and 8 I write as 20. So this is Vs. Find this I write as 20 ohm. This is 7 ohm. 6 and 6, if I two equal resistance, so total resistance is half of the single, so 3. This is 4. 4 plus 3 is 7 ohm, right? So this is 7 ohm. This is 7 ohm, right? So in this 7 ohm, how much current is flowing? Here 15 milliamps is flowing. Here it is 15. In this 15, here it is 15 milliamps, means this must also have 15 milliamps current. So here what should be the current? 30 milliamps, right? Okay, now we see what is V. V is equal to I into R. I we know 30 milliamps. 30 into 10 power minus 3. What should be R? Right? So again 3, 7, 7. So equal distance 3.5. It is 20. So what is it? It is 20. So it is 3 and 3 equal distance 3.5. 20 plus 3.5, 23.5. So if you simplify, what you get is 30 into 23.5. It is 0.705 volt. V is 0.705 volt. So the answer must be option A. So 0.705 volt. So the next question is, obtain the current IT for the circuit shown below. Right, so they ask this current. Whenever they ask problems like this, you start from right hand side, right? So first we simplify this resistor. This is 4 and 4. Two resistors are in parallel, equal resistance. So we have to divide. What is R equal? If two resistors are parallel, R equal is the equal resistance by 2. So this will give 2 ohm. So 2 plus 4, 6 ohm. These two are creating 6 ohm. Now this 6 and this 6 are parallel. 6 and 6. So if these two 6 are parallel, what is R equivalent? The resistance by 2. So it is 3 ohm. So now we got here as 3 ohm, right? So this is 6, this is 3. One resistance is 2 times the previous. Second resistance is 2 times the first resistance. So R equivalent is equal to I resistance divided by 3. So 2 ohm. So this will give 2 ohm equivalent. This is 3 ohm. So 3 plus 2, 5 ohm, right? So simply we can find. So R equivalent is equal to 5 ohm. So I is equal to V by R. So 25 by 5, 5 ampere, right? So the answer is 5 ampere. Okay. Option C is the right answer. Next question. Determine the power delivered by the current source in the figure, right? So what they have given? They have given current at this point. Okay. Okay, so current here is 4 ohm. I use current divider rule and find the total current entering here. So I total, right? Okay, so that's what I want to find. So total current through this branch is 4 ampere. So total current, current through this 2 ohm is, how can I find? Let us assume this is a total current. So I apply current divider rule. 4, okay, I find that. What should I get? So current, total current. I want to find the current through this 2 ohm, let us assume. So I into 4, opposite distance divided by total resistance 2 plus 4. That current is 4 ampere, right? So this indicates I is equal to 6 ampere, right? Now we got I is equal to 6 ampere. I we got 6 ampere. What is P? P is equal to I squared into R, right? So here 5 ohm. So I want to find total impedance here. This is 4 into 2. So R equivalent here is 4 into 2 divided by 4 plus 2. 8 by 6, it is 4 by 3. Here it is 4 by 3. There it is 5 ohm. So R total is equal to 4 by 3 plus 5. 15 plus 4, 19 by 3 ohm. So P is equal to I squared R. I is equal to 6 into 6 divided 9 to 19 by 3. That is 12. So it is 228 watts. So the option C is the right answer. Next one, find the current shown in the figure. So I want to find I. So it is a current source. I convert into equivalent voltage source and find the current through this 8 ohm. So it is 5 ampere, 12 ohm. If I want to convert into equivalent voltage source, it will be 16 amp. I is equal to 5, R is equal to 12 ohm. So V is equal to 16 volt. Current goes down, so it is like this, 60 volt with the series 12 ohm. Next to this resistance, what is that? 8 ohm. Next here 25, 30 ohm, 25 ampere. So 25 into 30. So this 30 ohm will come in series. 25 into 30 is 750. Right? So it will be 750. Right? Now it is 750 volt. So here what I get is 750 volt. Here what I get is 60 volt. So let us assume this is point A, node A, this is node B. So what is voltage across VAB? So difference between VB minus VA, VB minus, this is minus 60. It is minus, so it is minus 60. Minus of minus 60 divided by R. R is 12 plus 8, that 28, sorry, 20, 20 plus 30, 50 ohm. So VAB is equal to 16.2. Okay, right. So it is 810 by 15, 16.2 volt. Fine, 16.2 volt. So let us see. Sorry, I is equal to. It's sorry, it is not VAB. It is I. Please forgive me. So I is equal to VAB by R. VAB is this one, so I is equal to 16.2 amps. So option A is the right answer. Next one. Obtain the current IS in 10 ohm resistor in the figure. So I have to find this one. Okay, so again, this current source I convert into equivalent voltage source. I redraw the circuit. So it is 50 volt. Here no problem. This is 30 ohm. This is 10 ohm. 5 into 20, 100. Fine. So this is 20 ohm, 100 volt. I have to find the current through this. Okay. So let us assume here the potential is V. I apply KCL nodal analysis. So V minus 50 divided by, right? So it is V minus 50 divided by 10. Okay, so right. So next one. See here, this is not V. Please change it. So this 50 here also 50 volt. The same 50 amperes here. So let me take, this is the node, right? So this 30 in bottom we have another 120. So keep it this 20 here, right? Okay. This is 20 ohm. Fine. So now what we get is, from here you apply, this is V minus 50 divided by 10 for this branch, right? Plus V minus 100 divided by, this is 20, this is 20, so 40. So that is equal to 0. So this indicated 40V minus 2000. I take a LCM as 400, right? So minus 2000 plus 10V minus 1000 equal to 0. So if we simplify, what I get is V is equal to 60. V is equal to 60 volt. If V is equal to 60 volt, what is I? So I got this is 60 volt. The current I want to find, current through this, so this one, so I is nothing but 60 minus 50 by 10, right? So I is equal to, so I want to find the current through this terminal. So here 50, here 60, so 50 minus 60 by 10. So what I get is I is equal to 50 minus 60 by 10 minus 1 ampere. So the answer is option B. Okay. Next one, use the branch current in the network shown below. Find the current supplied by the source. Right. So this is a very simple problem. This problem I write it in a different way. So I redraw the circuit. This is 60 volt. This is 7 ohm. These are all in the same potential. I can interchange the resistance. 12 ohm, 12 ohm, 6 ohm. Right. So what is the thing? These two are equivalent resistance with equal values. So this one I can replace by R by 2. So 12 by 2, 6 ohm. Now these two are equal resistance. 6 and 6 are equal. So I can replace by 3 ohm. So total resistance I replaced by 3 ohm. So what is I? I is equal to V by R. 60 by 7 plus 3, 10. So 6 ampere. So the answer is option B. Okay, next one. Calculate the internal resistance of a battery which has an open circuit voltage of 12 volt and delivers a 100 ampere current to a resistance of 0.1 ohm. So this is internal resistance are also given. So what is my I? I is equal to V by load resistance plus internal resistance, that we know already. So that is V is nothing but 12 volt, RL 0.1 plus R I don't know. That current is given by 100 ampere. So if you simplify, this indicates 10 plus 100 R is equal to 2. 100 R is equal to 2, right? So R is equal to 0.002 ohm. Sorry, 0.02 ohm. So option D is the right answer. Okay. Next one, for the circuit shown in the figure, the value of R, find the value of R that will receive maximum power. Okay. So if I want to find the maximum power, what is the condition? R Thevenin should be R load. R load resistance must be equal to Thevenin's resistance. So Thevenin resistance, how can I find? I short the voltage source, remove the load. So what can I get? I get this circuit like this. Right? So this I shorted voltage source. This is 5.2. This is 7.1 ohm. Similarly, here it is 10.9. Here it is 19.6 ohm. So this resistance is the equivalent Thevenin's resistance. So I have to find the combo. So these two are parallel. I can redraw the circuit like this. Right. So this is 5.2, this is 7.1, this is 10.9, this is 19.6. So what is RL? R equivalent is equal to R Thevenin, which is equal to RL. R equivalent I can write as 5.2 parallel with 7.1. So 5.2 plus 7.1 plus 10.9 parallel with 19.6. So I can write like this. 10.9 plus 19.6. So it will be equal to 3. It will be equal to 7. So 10 ohm. So RL must be equal to 10 ohm. So RL is equal to 10 ohm means, you see, is there any other option in 10 ohm? No, here it is no. RL 2 ohm, 5 ohm. So option A is the right answer. You don't need to find the power, directly you can write the answer, right? Okay. So the next question is, a series RLC circuit contains 10 ohm resistor and a bandwidth of 0.5 kilohertz. What is the value of L? So R they have given 10 ohm. Bandwidth 0.5 kilohertz. What is L value? We know the relationship between bandwidth and RL in series RLC circuit is given by bandwidth is equal to R by L. This implies L is equal to R by bandwidth. R is 10 ohm. Bandwidth is 0.5 into 10 power 3. 20 millihenry. So 20 million is there. I think nothing is matching. So option A we can choose. There is no other option. Okay. Next one, the equivalent resistance of the network across 50 voltage battery. So here I can draw this circuit in a different way. This is 5 ohm, 10 ohm. This 20 I can draw like this. This 10 and 10 series, so I can draw like this 20. So now we can simplify. You see, this 20 and this 20 are parallel equivalent resistance, so that will give 10 ohm. So 10 ohm. Now you see this 10 and this 10 are parallel. So 10 parallel 10 will give 5 ohm. So what is the total resistance? 5 plus 5. So R equivalent across this 50 volt source is 5 plus 5 is 10 ohm. So option A is the right answer. Next one, yeah, resistance R is connected across an active network. It is given that when R infinity, voltage across R is 5 volt. When R 0, current output of the active source is 2.5 milliampere. What is the internal resistance? So you see we have a active network like this. Here one R is connected, right? So R infinity means open circuit. So when R is infinity, what is the voltage? 5 volt. Similarly, R0 means short circuit where current is 2.5 ampere. What is the internal resistance they are asking? R internal is equal to VOC divided by ISA. 5 by 2.5, it is 2 ohm. So option D is the right answer. And next one, the effective inductance of three inductors of inductance L1, L2, L3 are respectively connected in series. In series, it is inductor behaves like a resistor. So add all the things. L1 plus L2 plus L3. Okay. Three resistors 4, 6, 8 are connected across 36 volt. So this is 36 volt. 4, 6, 8. 4, 6, 8 volt. So what is the voltage across? 6 ohm resistor they are asking. You see the potential is directly proportional to I, proportionality constant is R. So R increases, drop will increase. So you see the ratio of the resistance, it is 2 is to 3 is to 4, right? So what they ask is what is the drop across 6 ohm. So what is the total resistance? Let us assume it is 9, 2, 3, 4. So out of 9, how much I have to get the drop? 3. So what is the total? 36. So total 36 into 3 by 9, it is 4, 1 volt. So the answer is option B. Suppose if they ask for what is the drop across 4 ohm, It is 9. Out of total 9, how much I have to get? 2 times. So it is 2 into 36. 8 volt. Here for this 8, it is 4 by 9 into this is 4 times, right? So 4 by 9 into 36, not 8, it is 36. So okay, 4 into 4 16. So total you see 16 plus 8 24, 24 plus 12 36. So here it is 12 volt, here it is 8 volt, here it is 16 volt, right? 2 is to 3 is to 4. If you divide by 4, you will see 2 3 4, the same proportion, right? So like that you can use logic, no need to use subject and all. Simply you can find the answer. Okay, the number of nodes n, the number of nodes n of a connected graph and number of branches are related as b is equal to n minus 1. So option C is the right answer. Next one, when the load is matched to a source, what is the maximum power? We know maximum power is V squared by 4RTH. So Vs squared by 4Rs. So option D is the right answer. Right? Okay. Right? Not R, 4Rs. Yes, not 4R square. R squared, it should not be there. Right? Okay. Next, the resonant frequency of a parallel resistor, whatever be the resonance, whether it is series or parallel, F naught is equal to 1 by 2 by root LC. So that is the answer. Next, a two-terminal bilateral linear DC circuit can be replaced by equivalent circuit consisting of voltage source with series resistance. If it is current source with parallel resistor, right? In that way we can replace. So option B is the right answer. Okay.